Inverting configurations. Inverting configuration. Summing, scaling, and averaging amplifiers. Summing, scaling, and averaging amplifiers. First one is summing. Here R1. This one is R1, R2, and R3 are the three resistances. This one is RF. The current flow through this RF is IF. This one is the virtual at summing point here. Plus terminal is connected to ground. That means the voltage at an inverting terminal is 0 volts. The voltage at X point is also 0 volts. V1 and voltages which are up inverting terminal of the op amp through three resistances R1, R. According to KCL at the point X, some of the currents enter into that load at that node X. This one is IB minus. Some of the currents means I1 plus, I2 plus, I3 is equal to these three currents are entering into that node X, and two currents IF and IB minus, IF plus IB minus. These two currents are away from the node. In ideal case, IB minus is equal to 0. Therefore, I1 plus, I2 plus, I3 is equal to IF. I1 plus I2, I3 is equal to IF. I1 is equal to V1 minus this voltage is Vx. Vx is equal to 0 volts according to virtual ground concept. Whatever the voltage available at non-inverting terminal of the op amp is same as the voltage available at inverting terminal of the op amp. That is 0 volts. Vx is equal to 0. Therefore, I1 is equal to V1 minus Vx by R1, but Vx is equal to 0. I1 is equal to V1 by R1. The similar way, I2 is equal to V2 by R2. I3 is equal to V3 by R3. IF is equal to Vx minus V out by RF. But Vx is 0. Vx minus V out by RF. But Vx is 0. Therefore, V1 by R1 plus V2 by R2 plus V3 by R3 is equal to Vx is 0. Therefore, minus V out by RF. V out is equal to minus of RF by R1 V1 plus RF by R2 V2, RF by R2 into V2, next RF by R3 into V3. Summing, this one is minus sign indicates 180-degree phase shift between input and output. V out is equal to minus RF by R1 plus minus of RF by R1 into V1 plus RF by R2 into V2 plus RF by R3 into V3. The output voltage is equal to the negative sum of all the input times the gain of the circuit. The gain of the circuit means here R1 is equal to R2 is equal to R3 is equal to R. Therefore, V out is equal to minus RF by R V1 plus RF by R V2, RF by R V3. That is equal to minus of RF by R V1 plus V2 plus V3. V1 plus V2 plus V3. The output voltage is equal to the negative sum of all the inputs times the gain of the circuit. The output voltage, the output voltage is equal to is equal to is equal to the negative sum of all the inputs, all the input in voltages times the gain of the circuit, times the gain of the circuit, gain of the circuit. This one is the gain of the circuit, gain of the circuit. When gain of the circuit is 1, gain of the circuit is 1, that means mod RF by R1 is equal to 1 minus mod RF by R1 is equal to 1. That is R1 is equal to RF is equal to is same. R1 is equal to R2 is equal to R3 is equal to RF. Here all are equal to 1. RF by R1. RF is also R. RF is also R. All are equal to R. Same. R by R into V1 plus R by R into V2 plus R by R into V3. That is finally we will get output voltage. V out is equal to minus of VA, the V1 plus V2 plus V3, minus of V1 plus V2 plus V3. The output voltage is equal to negative sum of all input voltages when gain is equal to unity. When gain is equal to unity. R1 is equal to R2 is equal to R3 is equal to RF is equal to R. In that case, V out is equal to minus of V1 plus V2 plus V3. The gain is unity. The output voltage is equal to output voltage is equal to the negative sum of all input voltages. Negative sum of all input voltages. That means minus of V1 plus V2 plus V3. Second one is scaling. Scaling or weighted amplifier. If each input voltage is amplified by a different factor, we know that V naught is equal to minus of RF by R1 plus RF by R2 V2 plus RF by R3 into V3. If each input voltage V1 is amplified by a different factor, that means RF by R1. V2 input voltage V2 is amplified by another factor RF by R2. V3 is amplified another factor RF by R3. If each input voltage is amplified by different factor are weighted differently at the output. Weighted differently at the output. then it is called a scaling or weighted amplifier. If each input, if each input voltage, is amplified by a different factor, by a different factor. The different factors are RF by R1, RF by R2, RF by R3. Weighted differently at the output. Scaling or anchor. This condition can be accomplished if RA, R1, R2, and R3 are different in values. That means RF by R1 not equal to RF by R2 not equal to RF by R3. This is the weighted one. This one is weighted one. Third one is average circuit. Average circuit. In case of average circuit, R1 is equal to R2 is equal to R3 is equal to R, and RF by R is equal to 1 by N. N is equal to 3. Substitute these conditions in the above expression. We know that V minus of RF by R1 V1 plus RF by R2 V2 R3 into V3. First condition is R1 is equal to R2 is equal to R3 is equal to R. RF by R V1 plus RF by R into V2 plus RF by R into V3. That is equal to minus RF by R V1 plus V3 minus if RF by R is equal to 1 by N. That means RF by R1 is equal to RF by R2 is equal to RF by R3 and so on and so forth. RF by R1 is equal to 1 by N generally. Here N is equal to 3. That is 1 by 3. Minus 1 by 3 V1 plus V2 plus V3. That is equal to V3 by 3. This is the averaging circuit in which the output voltage is equal to the average of all the input voltage. This is accomplished by using all the input resistors of equal values. That means R1 is equal to R2 is equal to R3 is equal to R. In addition, the gain by which each input is amplified must be equal to 1 over the number of inputs. That is RF by RN. RF by R is equal to 1 by N.